Hi there! Welcome to Raelene Math. In this video, we will take a look at the Pythagorean Theorem, one of the most famous equations in mathematics. It's an equation that relates the three sides of a right-angled triangle. We will prove the theorem, and then we will look to see how we can apply it to different topics or concepts in mathematics. The first thing we will do is prove the Pythagorean Theorem by considering a square of side length c. Rotating the square a little bit gives us a different perspective because we can introduce some vertical and horizontal lines which intersect at right angles and which allow us to create the right angle triangle that we wish to explore. We're going to do this a couple of times and we will create 4 different right triangles inside. Now this is pretty accurate, but I'm actually going to just bring up more accurate lines. The questions that we have then are, how are these 4 right triangles related? Are they similar? Are they congruent? Or neither? And what is this shape in the middle? Addressing that question first, we see that we have a straight line which has a total sum of angles of 180 degrees, which means that the missing angle here is 90 degrees. Therefore, all of these inside angles here are 90 degrees. So we either have a rectangle or a square if all 4 sides are the same length. The other question is, how are these 4 triangles related? I'm going to label some angles here. I'm going to call this theta. And then knowing that the missing angle of a right triangle adds to 90 degrees, because we have 90 here, these two add to 90, we have these 2 angles are complementary. Then this angle here must be another complementary angle because we have another right angle here. So this is again theta, which makes this complementary at 90 minus theta. And around we go. We have complementary, we have another complementary angle all the way around. And it turns out that all of the angles of the 4 right triangles are the same. Therefore, the 4 triangles are at least similar, but because they all have the same hypotenuse or longest side length of c, we indeed have 4 congruent, exactly the same triangles. Now let's label the legs of the triangle. The shorter one, the height here, or altitude, I will label with A, and the base along here, which is the longer of these 2 sides, is called B. Since the triangles are congruent, every smallest side is A, and the middle length is B, and the hypotenuse is C. As a result, then we can see that the length of this is B minus A, and if this is A, so is this distance along the vertical of this inside rectangle, which makes that this rectangle is a square. So just to recap, we've got 4 different figures. We have 4 congruent triangles, right triangles, and we have a square. Now to come up with a proof, what we recognize is that we have a square of area c times c, or c squared, and it's comprised of a multicolored figure. But they're the same figures, so we have that their areas are equal. And recalling the side lengths of the square are c by c, we have that the area of the blue square is c squared, and we can rearrange the multicolored figure into rectangles and squares to come up with its area. We have that the smaller length of the rectangle is A, and the longer side of each rectangle is B. And we also have that the side length of the yellow square is B minus A. So we see that the area of the multicolored figure is actually going to be 2 rectangles of area AB each, and a square with area of b minus a all squared. Expanding this gives us c squared equals 2ab plus b squared minus 2ab plus a squared. And when we simplify this, we get c squared is equal to b squared plus a squared. We can rearrange that the way it's typically seen, that a squared plus b squared is equal to c squared. And so this is really the Pythagorean theorem relating the 3 sides of a right triangle. The proof of the Pythagorean theorem boils down to finding areas of rectangles and squares. And now that we've proven it, we don't need to keep doing so in order to use the theorem. In the next 2 videos in the series, I will relate the Pythagorean theorem to the distance formula between 2 points in the Cartesian plane, as well as to the equation of a circle, the trigonometric identity cos squared theta plus sine squared theta equal to 1, and to the calculation of the magnitude of a vector. If you like the video, click like and subscribe to my channel. Thanks for checking out Raelene Math.